Hey, welcome back. This is video number 8. I wanted to start by thanking you for your patience. I know this one is a little bit late going up. So right now what you're seeing is the sort of key slide for this video, and that is a slide that talks about types of bias. So in this video, we'll be talking about bias versus error. Bias and error are different things. And then we'll briefly talk about reliability and validity, which are two key concepts when you're trying to talk about the sort of quality of measurement. Okay, let's get started. I should mention that you should have your build your own textbook out and be, furiously scribbling and perhaps stopping to take notes or stopping to ask a friend or stopping, just sort of stopping to make sure you're getting these concepts. Types of bias, as well as the concepts of error and reliability and validity, will be on quiz 2. So just so you know. All right. So the first thing I want to do is make an incredibly important distinction that is sort of different from the way we think about this distinction in regular life. So in this class, bias and error are really different. Error is something random, and we love error, or rather, we expect error, because error is just what happens when you sample randomly. So it is the kind of wrong you are when you have done everything right and you just happen to get a slightly weird sample. That is why, for example, polls have margins of error. Polls are, if they're reputable polls, they have high quality and nevertheless occasionally just get the wrong answer. That should be distinguished really carefully from bias. So bias is getting it wrong systematically. And I want to also clarify that you don't have to be biased to create bias. That is to say, not all bias comes from, say, a political orientation, twisting the data to fit your nefarious ends or something like that. Bias is any kind of systematic, as opposed to random, error. So there's so here's an example of a poll that is both systematically biased, and the type of bias involved is a political bias. That is a poll that I recently saw on whitehouse.gov that asked whether you think Donald Trump is, let's see, I'm looking at my notes, good, excellent, amazing, I think was the third choice, and then the fourth choice was other, right? So there's no option to say that I don't approve of Donald Trump. Exactly. That all falls under other. And that's a pretty clear example of political bias. Donald Trump is not the only one who does polls like that. I recently received one from the Elizabeth Warren campaign. But political bias is far from the only kind of bias. So in my area of work, which is bad things that happen to people in war, we often use data from humanitarian organizations, and frequently we get data from humanitarian organizations in areas of the global south where road networks are crappy. And those data often say things like, hey, there's a cyclical pattern to violence. It goes down during the rainy season. Now, that might be true. Or it might be, as is the case in large swaths of Central America and Africa, that in the rainy season, you can't get to the places that violence is happening over roads that are flooded, right? So your reporting goes down. It's not correct, and it's not correct in a systematic way. But that's not because humanitarian organizations are politically biased. It's because they don't have the wherewithal to gather the data they need in that instance. So that is an example of bias that is not political, but is still, right, that's a systematic error. So what I'm going to talk about now is on this slide you're looking at. What I want to say first is that ordinarily, people treat survey data and observational data, which is basically everything that's not a survey or an experiment. They treat survey data and observational data pretty differently. And I'm going to only kind of do that in this class. I think that there are concepts from survey data that can be really useful to us in the context of observational data and vice versa. So, some things to know about types of bias in surveys and observational research. Down the left-hand side, you see sources of bias. And across the top, you see the two different types of data I just mentioned, surveys and observational data. So let's look at survey data first, since that's what we're going to be doing in the next couple of weeks. So in a survey, when the bias comes from the construction of the sample, we call that, I know you're shocked, sampling bias. And again, this isn't random error. This is systematic overrepresentation or underrepresentation of some types of people in the sample. So, for example, if you were to try and do a poll on American public opinion and you accidentally only got phone numbers from Fargo, North Dakota, that would not be representative. It would overrepresent white people and underrepresent people of color. It would overrepresent middle-class people and underrepresent both rich and quite poor people relative to the US population. It's also wrong in a whole host of other ways, but that's sampling bias. You're wrong because of something about your sample. The next type of bias in surveys is typically referred to as non-response bias, and that's from people that don't answer. Unfortunately, what we find is that people that do and don't answer are systematically different on a variety of levels. So people that don't answer polls are typically less politically engaged. People that don't answer polls are often people from marginalized groups, or people of lower socioeconomic status, people who don't have time, energy, etc., or don't feel they have the expertise to respond to a poll. Non-response bias is an enormous political issue in the United States right now, largely because our census is not a poll, but it is strongly affected by non-response bias in the sense that people from the South, African Americans, Native Americans, poor people, people in extremely urban environments, and a whole host of other sort of demographic subtypes are people who are much less likely, on the whole, to return their census forms. And that leads to a whole host of weird outcomes, wherein, for example, North Dakota is a little bit overrepresented in Congress because people in North Dakota are more likely to get counted in the census. Okay, so other sorts of non-response bias. One of the data sets that I work with the most is data on US military personnel and their experiences of intra-military violence. So it's a survey that goes out every year to everyone a large sample, a large random sample of the US military. And it has a tiny response rate, or it has a problematically small response rate, as low as about 25% among enlisted people, and only as high as about 40% among the top sort of echelon of officers. And the thing that we can't know based on that is how different are the people who do respond from the people who don't respond. And that leads to big fights, fights about whether, for example, if non-response is not biasing the data about intramilitary violence, then we can use this sample to make at least some inferences about the actual incidence of violence between members of the military. But what if people who have experienced violence become invested in the issue and become more likely to return their surveys? That means we're going to overestimate violence in the general population. of the military, right? Because a greater proportion of people say they experienced violence because people who didn't experience violence just didn't return the survey. Another faction can say, oh, well, no, experiencing violence from somebody that you're supposed to really trust, like a member of your unit, is pretty traumatic, and people don't like to disclose that stuff on surveys. So this group of people actually thinks that those people are less likely to turn in surveys, and that therefore we are underestimating violence between members of the military. A thing that I want to point out is that you can't tell the difference. You can make some hypotheses, you can design further studies to try and get at it, but you really have to think that it could be both, it could be neither. There could be something else going on that's even bigger. But again, as I flagged in class, this is fundamentally a creative exercise in thinking, okay, well, they can sample representatively, but they can't make people turn in their survey forms. So what's going to be missing? What's likely to be missing? Okay. Finally, on the survey front, basically incorrect measurement. And on a survey, because surveys have respondents, we call it response bias. This includes social desirability bias, which is anything where you might be embarrassed to tell the real answer. So that's, have you had an abortion? Do you have HIV? Have you experienced sexual violence? Are you involved in a non-monogamous relationship? Do you regularly steal from the candy store? Anything like that. Even measures, and this is important in American politics, measures of sort of race attitudes and measures of attitudes toward women often, not always, can be biased by social desirability bias. People also like to say yes. So people often will be like, yes, 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 thereby biasing the results of their survey. Some people like extreme responses, right? If you have a 1, 2, 3, 4, 5, they're always going to choose 1 or 5. Some people have the opposite bias and they always choose the middle response. Again, it's quite hard to tell the difference between people who sort of fill out surveys carelessly and therefore show that sort of pattern versus people who actually have really strong opinions or actually have no opinions. It's quite hard to tell from any given data set sitting in front of us. And then finally, question wording effects, which we'll talk about more in class. So on the observational side, the thing I want to say is that there's no clear distinction between sampling bias, since often what we're trying to do is record all the cases, the universe of cases, and non-response bias. Non-response bias is maybe analogous to missing data that you don't know is missing, right? So that is the question about humanitarian organizations and violence during the rainy season. We don't know whether there's actually lower violence during the rainy season or whether this is a problem with muddy roads. But in therefore, in observational data, we kind of group both sampling issues and non-response or missing data issues together as selection bias. The kind of most famous article, which I used to teach, is by Barbara Geddes, who's a UCLA political scientist, and it's called How the Cases You Choose Affect the Answers You Get. And she's thinking about sampling, but that's also the case when we're trying to count things or measure things. So both of those types of things fall under selection bias. If you're feeling a little stranded at this point with this big concept of selection bias, just think of it as everything that gets into and therefore everything that doesn't get into the data. Okay. Also, we're going to talk about it in class. Finally, there's a lot of ways that observational data can be biased also. So the analogy to response bias in the survey context is a variety of things that can go wrong, even if we sort of have all of the underlying information. Things can still go wrong. We can get bad underlying information. There are countries that are really crappy at measuring their own GDPs, but guess what? The World Bank has to use those estimates anyway. And we don't really know whether all GDP estimates are almost right, or whether, for example, in countries with big black market economies, we're actually missing a huge chunk of GDP. There's also incorrect coding. So, a famous data set called Polity measures the quality of democracy across the world. And it turns out that people from the United States sitting in an office in the United States, even though they have a very clear, well thought out coding rubric in front of them that says, okay, you give it a 4 if there's this much judicial independence, they may still code differently according to their sort of preconceived biases or earlier information they may have had. So they might just basically write the wrong answer. Um, and then finally, a lot of observational data relies on quantifying or assigning numeric values to underlying information. For example, there are several data sets based on the yearly country reports from the US State Department. But we know that the US State Department is not like a neutral entity. So very often we see these reports sort of go easy on regimes that are friendly to the United States. And those biases end up in the data, even when people are coding them correctly. And that is incorrect measurement. That is bias in the observational context. All right. I'm going to leave the slide up while I talk about these last two issues, but I'm going to move on. So, well, actually, maybe I'll make the slide little, and you can look at a picture of Henry. Yeah, hi Henry. While I talk about these last two concepts, the concepts are first reliability and second validity. Reliability means you get the same answer every time you use the measurement instrument. So, for example, if I were to take the SAT several times, I don't know why I would want to do that, but if I had, and I didn't study or practice in between, I would likely get roughly the same score each time. That's reliability. Validity is whether the thing is measuring what it says it's measuring. The SAT is called the Scholastic Aptitude Test because it thinks that it is measuring so-called scholastic aptitude, whatever that is. There's been a variety of research on the SAT that suggests the SAT is not a valid measurement of, of scholastic aptitude. It might be reliable, but it's not particularly valid because it mixes up a lot of stuff with scholastic aptitude. So it measures whether you're smart, sure, but it also measures whether your parents can pay for an expensive SAT prep tutor. There's a huge effect of things like parental involvement, of parental resources, school environment, the list goes on. So, an invalid measure is the same as saying a biased measure. And again, that might be a political bias, or it might be a sort of accidental yet still systematic bias. So again, just to recap, reliability is it gets the same answer every time or most times. Validity is it measures what it says it's measuring. Excuse me. The last thing I'll say about validity and the last thing that I will say about reliability and validity is that something can be quite reliable and not valid at all. The SAT is a pretty okay example of something that is reliable but not necessarily valid. And it is much harder. In fact, I would say impossible. You might as well go ahead and think of it as impossible to find a measure that is valid but not reliable, right? Because if it's measuring what it says it's measuring, then it should be measuring in the same range most of the time, right? Yeah, that sounds true. Uh, somebody who is 5 feet tall, even though there might be small ruler problems, that person should always measure in the approximately 5 feet tall area. Okay, so reliable but not valid, that's a thing. Valid but not reliable, not so much. All right. That is the end of this particular conceptual lecture. In lecture 9, we will be taking our studio for a spin. So take a break, and I will see you next time. Thanks, everyone.